Hi everybody, in this video we're going to look at the average rate of change.
The average rate of change of a function f of x over a closed interval ab, where f of x is continuous over the interval, is f of b minus f of a over b minus a. Basically, it's the slope. Let's start with an example of how car loans have changed over time. So this says over 100 million Americans have auto loans. The graph shows the number of car loan accounts in the U.S. by year, and the numbers are given in millions. We'll start by finding the average rate of change from 2003 to 2017. When you look at the graph, you can see that the number of loans has kind of decreased over time. So it kind of went up, it went down a little, and it went up again. But by finding the average rate of change, we're really making a line from 2003 up to 2017, and we're looking at the slope of this line. To find the slope of this line, we would take 108.7 minus 74, and I would divide that by 2017 minus 2003. Simplifying, we get 34.7 over 14, or a slope of 2.48. This says, on average, the number of car loans in America has increased by 2.48 million loans a year. If we go back and change the years that we're looking at, we might see a different slope happen. So this time, let's look from 2003 to 2011. Again, what are we doing? We're finding the slope of the line connecting these points. So look at 2003 to 2011, and we can see it's not as sharp of an increase over this time period. So the 2003-2011 gives us 80 minus 74 over 2011 minus 2003. So the amount it changed was 14 over those 8 years, which is an average of 1.75. By looking at the average rate of change, we're only looking at the first value and the last value. So we missed the fact that the values went up and down over that time period, and we kind of ignore it. We're only looking at the start and the finish. Let's try again. This time I'm looking at stock prices. I picked GameStop. Going back to 2017, it goes up to 2021. In the chart that I added on top, I just pulled a number from January of each year. So I have 2017, 18, 19, 20, and 21. And we can see that big fluctuation in prices over the time. What's interesting is from 2017 to 2020, there wasn't a huge change. You can see it looks pretty flat in our graph. But then when you look at 2021, there was a huge amount of change. So we're going to start from 2017 to 2020. So 2020, the price was $24.52. In 2017, the price was $5.43, and that was over a 3-year period. So this reduces down to a 19.09 change in price divided by 3 years, which says it went up about $6.36 per year from 2017 to 2020. Let's change the values again. This time, let's look from 2018 to 2021. I want to look at the price in 2021, which was $347.51. I'm going to compare that to the price in 2018, which was $15.24. Again, this is over a 3-year period. So my difference, $332.27 increase in price divided by 3, says on average, the increase in price was 110.76 cents per year. Looking back at our chart, we can see that really didn't happen. It wasn't per year that it increased from 2018 to 2021. It was kind of overnight. So what happened again is it gets hidden in there a little, that instead of showing that there was an increase at 2021, it spreads it out over the time and gives the average change in price over the time period. So let's try this again. This time I have the value of a stock can be modeled by the function v of x is 56x plus 7x times 2 minus x plus 5. X is the number of years after it was purchased. We're going to find the average rate of change over the intervals 0, 4, 0, 8, and 3, 7. To make this a little easier, let's go to Desmos. In Desmos, I'm going to start by typing in the function v of x is equal to 56x plus 7x times 2 minus x plus 5. And then I want to have it evaluate the function for me. So our first interval was 0 to 4. So I can do v of 0. I can do v of 4. In fact, I could have Desmos do the whole thing. So I'm going to put a parenthesis, v of 4 minus v of 0, and then divide by 4 minus 0. So notice how I put parentheses around the numerator and denominator. That helps Desmos understand the order of operations. So over that 4-year period, the increase from 5 to 73 was $42 a year. The next interval that we have is 0 to 8. Again, let's put in v of 8 just to get an idea of the value. So now the value after 8 years is $117. It's gone down from the 173 we had before. And then I'm going to have it do the whole average value for me. So I'm going to do v of 8 minus v of 0 and divide by 8 minus 0. Again, pay attention to the parentheses to give order of operation. So this time it says the average rate of change from initial purchase to 8 years later is that it increased $14 a year. So one more. Our last interval was 3 to 7. So when I look, I like to see the values. So I'm going to do what was the value after 3 years? What was the value after 7 years? So I can see the value after 3 years was 152. The value after 7 years was also 152. So watch what happens when I put that together. I have parentheses v of 7 minus v of 3 divide by 7 minus 3. And because the values were the same, it comes out to be 0. So this shows that the price in 3 years and the price in 7 years was the same. So if I looked overall, I would say how much did I gain per year? And I gained nothing if I've come back to the same value that I was at. We could go over to the graph and kind of look at it to get a better view. So I'm going to change the settings for the axis. So I'm going to say the x, I really needed to start at 0. And let's go over to 10. And the y-axis also start at 0 because it can't be negative. And we had a value that was 173, so I'm going to go a little higher. Let's say I go to 220. Now I can see what happened to the value of the stock over time. It went up and then it went down. So if I had any of these particular points, then I could see what happened over time. And we could have it put the points on. Easiest way to show some points would be to hit the edit. And by the function that we ended, we're going to put in a table. And I'm going to put the values we looked at. So we looked at 0, we looked at 3, we looked at 7, we looked at 4. So now I can see these points on the graph. And you can tell these differences of time, right? So what happened? So we started really low over here at 5, and it was increasing over time. So this is at 2, here's 3, here's 4. And look at 7, where it was the same thing as 3. So I have this value right here where I can see there was no change versus other times there was a big change. So moving on, we want to get to derivatives. And the main goal of the derivative is not to have 2 points. We want a way to describe how a function is changing at a singular point instead of the 2 points that we talked about when we did the average rate of change.